Welcome, my remainder rascals. We just finished long division part 1. If you didn't watch that, I recommend you watch it. It's in the link below in the comment section. But this is part 2. I'm going to sort of up the ante a little bit and do slightly more difficult problems. And so if you're doing long division problems with 2-digit, 3-digit, 4-digit numbers, if you're doing long division with decimals, this is the video for you. Don't forget to like this channel. Don't forget to subscribe to this channel. Don't forget to like this video. Don't forget to subscribe to this channel. I'm coming at you with all sorts of mathematics from all sorts of levels. So let's get to it. Let's do an example where we have 6,752 divided by 10. Now what makes this a part 2 problem is that's a 2-digit number. And we didn't deal with 2-digit numbers in the previous video. We only had this being a 1-digit number. But the idea is the same. If you understand what we did in the previous video, then this shouldn't be too much more difficult. It just takes a good deal of practice. Alright? So, we do the same thing. We ask ourselves, how many times does 10 go into 6? And of course, 10 does not go into 6. And so we move over and add another digit here. How many times does 2 go into 67? Hey, 6 times. 7's too big, that would be 70. 5 is too small, right, because that would be 50, and there would be 17 left over, right? Let's just do that off to the side real quick. If I thought it was 5, I would do 5 times 10 is 50, and when I subtract it, I would get a 17 as my remainder. Your remainder can never, ever, 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 ever be larger than what your bottom number is, what your divisor is, and so that wouldn't work. But 6 times 10 is 60, and I subtract 67 minus 60 is 7, and that's a-okay, because 7 is a smaller number than 10. Now, what we do in long division is I take this 5 and I bring it down, and then I ask, how many times does 10 go into 75? 7 times. Because 7 times 10 is 70, I subtract these two numbers, I get 5. 5 is smaller than 10, so that's all good. I bring this 2 down. How many times does 10 go into 52? 10 goes into 52 5 times. 5 times 10 is 50. Subtract, and I get 2. So we could write our answer as 675 remainder 2 if we wanted to. We could write our answer as a fraction, as a mixed fraction, 675 and 2 over 10. And then, of course, you want to simplify your fractions, folks. 2 over 10 is the same thing as 1 over 5. If you need a refresher on simplifying fractions, the link to that is in the description below. Or maybe we are required to write this as a decimal. And so I put an extra digit behind there, a decimal point, because 6,752 is the exact same thing as 6,752.0. And I'm doing this because I just need another digit to drop down. How many times does 10 go into 20? So I put a decimal point right up above this decimal point right here. 10 goes into 20 twice. And now I'm done because 2 times 10 is 20. And I subtract those. I have nothing left, no remainders, and so my decimal has terminated. And so I get 675.2. Now, this was a tie-in example to the stuff I did in part 1, where I do remainders and mixed fractions and decimals. And it's the same thing, they're just different ways of writing the exact same number. For all intents and purposes, I'm just going to do the remainder for the remainder of this video. Alright, perhaps in the practice problems that I do, I will supply all the ways of writing the answer, but for the sake of time, I will just do the remainder version from now on in this video. So let's do another example. Let's up the ante a little bit. Let's do 12 into 1,782. Now, the reason why this is slightly more involved is because I like working with the number 10. Things just work out nicely. It's a nice whole number. Now, 12 is also a whole number, but it doesn't end in a 0. It's a 12. It's not as nice, but it's still doable. How many times does 12 go into 1? It doesn't. How many times does 12 go into 17? It goes in there once. And then we multiply. 1 times 12 is 12. We keep these nice and lined up. Keep your work neat. Notice if I start drifting and if things aren't in line, this is going to get very, very complicated and very messy right away. My piece of advice to you here is please, 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 please pay attention to your work. Make sure it's nice and neat and orderly, especially in long division. If you start misaligning things, you're going to be in a world of hurt. So don't do that. 17 minus 12 is 5, and I bring down the 8. Now, I'm going to do the next step wrong because I want to remind you what it looks like when it's wrong. Because I got to ask myself, man, how many times does 12 go into 58? That's a 2-digit number going into a 2-digit number. Let's say I say it's 3. It's not 3. How do we know it's not 3? Well, 3 times 12 is 36. And if I were to subtract those, I get 8 minus 6 is 2. 5 minus 3 is 2. I get a remainder that's bigger than my divisor. That cannot happen. So that's how I know that the answer is not 3. Now, I'm doing math in pen, which you should never do, but trust me, I'm a professional. So I ask, how many times does 12 go into 58? And you know what? You may think it's 3, and you'll know you're wrong because you'll get 22, which is too big for a remainder. That's totally fine. Some of this is trial and error. As a matter of fact, the examples that I have on my note sheet here, I've never done before. So I might stumble through these and guess incorrectly. That's totally fine, as long as you know what to look for and how to catch your mistakes. So, how many times does 12 go into 58? Well, let's just think about that real quick. If it's 4, that's 48, and I have 10 left over, which is what I want. Because if I do 12 times 5, I get 60, and 60 is too big. So, 12 times 4 is 48, and I subtract 48 from 58, and I get 10. And now I know I'm in business because my remainder is less than my divisor. That's how you know you're A-OK. And then I bring down this 2. I ask myself, how many times does 12 go into 102? Now it's a 2-digit number going into a 3-digit number. There's room for error. There's room for trial and error. Don't do math in pen like I'm doing, because you're probably going to make a mistake and guess incorrectly at least once or twice on a worksheet or something. All right? And that's totally fine. 12 goes into 102 8 times, because 12 times 8 is 96, and when I subtract these two values, I get 6. Okay? So this right here is equal to 148, remainder 6. That is 1,782 divided by 12. You know what? I said I'm not going to do the other ways. Let's do the other ways for this problem too. All right? The other forms of the answer. We can do 148 and 6/12. But hey, wait a minute. 6 over 12 is the same thing as 1/2. Or if we want a decimal representation, I do an extra 0.0 at the end. I drop that down. 12 goes into 65 times. Don't forget to write a decimal point right above the one that we just created. 5 times 12 is 60, and now I'm done. Which should be no surprise because 1/2 is 0.5. And so I can also write this as 148.5. Okay, so now we have 10,418 divided by 31. Does 31 go into 1? Nope. Does 31 go into 10? Nope. But 31 does go into 104. Now, this is where you're going to maybe have to do some guessing, some trial and error. I'm a professional. I know that it's 3. I write the 3 above the 104 because that's where I've successfully been able to divide 31 into. All right, so 3 times 1 is 3. 3 times 3 is 9. And now I subtract these two quantities. And I get 11. And I know I'm on the right track because my remainder of 11 is smaller than 31. So everything is good. So now I bring down this 1. And now I can kind of cheat, okay? Because 31 went into 104 3 times, and now here's 111, and that's not that much different than 104. As a matter of fact, it's only 7 more. So I'm going to have a remainder of, well, let's see. All right, 3 times 3 is, or sorry, 3 times 1 is 3, 3 times 3 is 9. Subtract these. I borrow 1 from the 10 spot. I get 7 plus 1 is 8, and then I get a 1, right? I only got 7 more of a remainder, but it's still less than 31, which is a-okay. And now I might have to do a little bit of thinking here, because I bring down that 8 and I get 188. Now 93 ain't going to cut it. Putting another 3 up here is not going to get me to where I want to be, because there's a bunch left over between 93 and 188. So maybe it's 4. Let's try 5. Okay? Let's see what happens. 5 times 1 is 5. 5 times 3 is 15. And now let's subtract these two quantities. All right? 8 minus 5 is 3. 8 minus 5 is 3. Uh-oh. I'm going to pause here. Let's see if you can see what's wrong. My remainder is too big because my divisor was 31. So 5 wasn't big enough, and that's totally fine. Let's go ahead and just erase that work. You shouldn't be doing math in pen like me. You should erase it and put a 6 right there, and that's totally fine. I'll tell you what, I'm going to be totally 100% honest with you. I thought it was going to be a 5 right there. I really did. Just glancing at it real quick, I was like, oh, it's going to be 5. But that's totally fine. Be comfortable being wrong every once in a while and just fix that mistake. Understand what to look out for. Fix that mistake. That's part of math, is being wrong a whole bunch. I've probably been wrong in math more than I've been right, like, ever. So that's totally fine. 6 times 1 is 6. 6 times 3 is 18. And now when I subtract 188 and 186, I'm left with 2. 2 is definitely less than 31, and so my answer is 336 remainder 2. Or I can write that as 336 and 2 31sts. Now here's a problem where the divisor is a decimal. What do we do with that? Well, this is 652 over 1.3. Now remember, in math, when you multiply by 1, you don't change anything, right? If I were to take this and just multiply it by 1, I get the same thing, 652 over 1.3. So multiplying by 1 isn't that big of a deal. It doesn't change anything. But I'm not just going to multiply by 1. I'm going to multiply by a clever choice of 1. I'm going to multiply by 10 over 10. Remember, anything divided by itself is 1, as long as that something is not 0, right? So 10 divided by 10 is 1. So I'm just multiplying this 652 over 1.3 by 1. Why the heck would I want to do this? Well, multiplying things by 10, move decimal places over. And so I get this problem. Okay? So this division right here is the same exact thing as 13 going into 6,520. Here's a very common mistake. Students will move this decimal point over, but they'll forget to do it over here as well because they don't even see the decimal point. You got to do it to the top and bottom because you multiply the top and the bottom by 10. So, how many times does 13 go into 6? What doesn't? How many times does 13 go into 65? Well, it's 26 twice. And you can do 3, maybe 4 times. 4 times 3 is 12. Carry the 1. 4 times 1 is 4, plus 1 is 5. And when I subtract these two quantities, I get 13. All right, now I'm going to pause and let's see if we can figure out what happened. There's something wrong here. You see it? It's very tempting to just get into the habit of moving on and carrying on, but notice that my remainder is my divisor, which means that 13 actually goes into 65 evenly. 4 was too small. I can fit another 13 inside, right? 52 plus another 13 plus one more 13, that's going to get me all the way up to 65 evenly. So that's okay. These things happen. Erase it. Actually, let me not scribble things out like that. Let's just start all over since I'm doing my work in pen. We've just established that this can actually go in evenly 5 times. 4 wasn't big enough because I get 65. And when I subtract 65 from 65, I get 0. I bring down my 2. Now, how many times does 13 go into 2? It doesn't. 0 times 13 is 0. Subtract and I get 2, which is totally fine because 2 is less than 13. I bring down this 0. 13 goes into 20 one time. 1 times 13 is 13. Subtract and I get 7. And 7 is my remainder. And so I'm going to write this in terms of the original problem. 652 over 1.3 is 501, remainder 7. All right, my next example, I have 2 decimal places here in my divisor. So I need to move those over twice. And so I need to do 634 into 9,241. Do you see my mistake? I hope so. I move this decimal place over twice. I need to do it as well here because now I'm multiplying the top and bottom by 100. In order to move this one over twice, I need to multiply this one up here by 100 to move this decimal place over twice. 1, 2. Okay? Because 100 divided by 100 is equal to 1. So I'm not changing the value of this thing because I'm just multiplying it by 1. But I'm multiplying it by a clever choice of 1. So I need to make sure to move this decimal place over twice as well. So how many times does 634 go into 9? It doesn't. 92? It doesn't. 924? 1 time. 1 times 634 is 634. Subtract. 4 minus 4 is 0. 2 minus 3, I need to borrow a 1 from my 100 spot. So that's a 9 right there, and that's a 2. Totally a-okay because 290 is a pretty big number, but it's still less than my divisor of 634. So I know I'm in good shape. I bring down that 1. How many times does 634 go into 2,901? Now here's what I do. Let's cover up 2 decimal places here. Or not decimal places, but digits. Okay, cover up 2 from the divisor, cover up 2 from here. Ask yourself, how many times does 6 go into 29? 4 times, because 5 would be too big. That would be 30, right? And so that gives you a place to start. If you're getting overwhelmed all of a sudden that we're dealing with 3-digit and 4-digit numbers, that's totally fine. Cover up a digit. How many times does 63 go into 290? Nah, that's still kind of too big for my brain. How many times does 6 go into 29? Oh, that's more reasonable. 5 would be too big. Let's try 4. Now 4 is not a guarantee because I'm still multiplying 4 by this 34 here, which I didn't take into account, but it at least gives me a place to look. And if 4 is too big, then I can go down to 3. Okay? 4 times 4 is 16. Carry the 1. 4 times 3 is 12, plus 1 is 13. Carry the 1. 4 times 6 is 24, plus 1 is 25. Whew. Subtract. 1 minus 6, I need to borrow something from here, but I can't borrow from 0, so I'll borrow 8 from here to make that a 10. I'll borrow 10 from there, like so. So 11 minus 6 is 5. 9 minus 3 is 6. 8 minus 5 is 3. And I am a-okay because this remainder of 365 is smaller than my divisor. So all is good. This is where being neat and orderly is very important because I need to bring down this 0 right here. Not that one, not the last one, but that one right there. How many times does 634 go into 3,650? Too big. Let's cover up some of these values right here. How many times does 6 go into 36? 6 times. But here's the thing, folks. If I make that a 6, and I multiply it by this 34 that I covered to estimate, it's going to be bigger than 3,650. Okay, if you don't believe me, go ahead and throw a 6 up there. It's not going to work out for you. You're going to get a number when you multiply 6 by 634, it's going to be bigger than 3,650. Let's just do it right real quick on the side here. 634, let's say you wanted to put a 6 up here. 6 times 4 is 24. So put a 4 here, carry the 2. 6 times 3 is 18, plus 2 is 20, carry the 2. 6 times 6 is 36, which is good, but then I add this 2 and I get 38. So when I subtract this and that, I'm going to get a negative number. Again, I knew that because putting a 6 up here will give me 6 times 6 is 36, but then this 6 multiplied by this 34 is clearly going to be bigger than 50. So the resulting number down here is going to be way too big. So I'm going to throw a 5 up there. 5 times 4 is 20. Carry the 2. 5 times 3 is 15, plus 2 is 17. Carry the 1. 5 times 6 is 30, plus 1 is 31. Subtract those numbers. 0 minus 0 is 0. I can't take 7 from 5, so I borrow some from here. 15 minus 7 is 8. 5 minus 1 is 4. I'm in good shape because 480, my remainder, is less than 634. So I bring that 0 down right there. All right. And I get 634 going into 4,800. So 6 times 8 is 48. So that trick might work, except for the fact that once again I have this 34 here. Not good. And so what I do is and again, you can try it over here. If you think 8's the candidate for up here, you can go ahead and try that, but 8 times 634 is going to be bigger than 4,800. So I'm going to go 1 down. 7 times 4 is 28. Carry the 2. There's already a 2 up there. 7 times 3 is 21. Plus 2 is 23. Carry the 2. 7 times 6 is 42. Plus 2 is 44. Subtract. And I can't borrow, or I can't take 8 away from 0. I can't borrow from that 0. And so I will go ahead and do that. And then that's a 10, so I'll borrow 1 from 10. Let's see. 10 minus 8 is 2. 9 minus 3 is 6. 7 minus 4 is 3. 4 minus 4 is 0. And I'm done. There's no more zeros to drop down. Okay? So we can write this number as 1,457 and 362 over 634. Like that. Okay? Now that's a mess. I definitely know that 2 goes into both of these. All right, let's cancel a factor of 2 from the top and bottom. Let's simplify that fraction a bit. So 2 goes into 36 18 times, and then goes into 2 once. And let's see, 2 goes into 6 3 times. 2 goes into 3 once with 1 left over. 2 goes into 14 7 times. And I'm not sure if that's totally simplified, but that looks pretty good. So that would be the mixed fraction version of my answer.